we want to take this region R and revolve it about the y-axis and then figure out what the volume of that solid looks like. So we've got a couple of things we need to do before we can really set up the integral that's going to do that for us. First thing we need to realize is that since we're revolving about the y-axis, we have to do everything in terms of y. So that means all of our curves have to be expressed as functions of y, and our bounds have to be expressed in terms of y. So we've got one function here, y equals 1 over x squared. And we want to solve that for x in terms of y. So if we solve it for x in terms of y, we're going to get 1 over the square root of y. Right? A good question would be, why am I using positive 1 over root y and not negative 1 over root y? And the answer is because this lies in the first quadrant, right? The negative version of that would be over here, right, in the second quadrant, and we don't need that piece. We also need the bounds to be in terms of y, right? So one of them is already given to us, which is nice. So we know that the top bound is y equals 4. Then the question is, well, this is the bottom edge of the region. What is that corresponding x value? Well, we find intersections of curves by setting things equal to each other, right? So in this case, I want to figure out when y equals 1 over x squared, which is the same as, in this case, x equals 1 over root y, meets x is equal to 4. Right? So I can either take this x is equal to 4 and plug it in here and solve for y, or I can take that x is equal to 4 and plug it in here and see what y has to be. It seems to be the easier of the two, so let's just do that. We've got 1 over 4 squared, so that's 1 over 16. Right? When x is equal to 4, y is equal to 1 over 16. Okay, so we know where things intersect. We know what our lower bound for our integral is going to be. We know what our upper bound for our integral is going to be. The next question is, what actually goes inside the integral? The way I like to do that is go to the axis about which you're revolving, draw a line through your region. For one thing, you want to make sure that that line hits the same curve when it enters the region as it does when it's exiting the region. In this case, it does, right? So any horizontal line we draw this way coming off the y-axis through the region is going to always hit the 1 over root y curve first, and then 4. Okay, so what we want to do is we want to say, well, what is the distance from the y-axis, which is our axis of revolution, to the entry curve, right, or first boundary, and what is the distance to the second boundary? So I'm going to call those R1 and R2. And then what we want to find volume is we want to integrate pi times, in this case we said our bounds are 1/16 to 4, of R2 squared minus R1 squared. And since we're revolving about the y-axis, we said again, everything should be done in terms of y. R2 is easy, right? It's determined by this vertical line, right, which is parallel to the y-axis, so it's always 4 units away. For R1, well, how do you measure distance from the y-axis? Using this function, right? This function of y tells you how far from the y-axis you are for any given value of y. So that's my R1. And with all this information, now we're good to go. So the volume is going to be given by pi times the integral of 1/16 to 4 of 4 squared minus 1 over root y squared. We've done all the hard work, now is the easy work of integrating, right? So you've got this pi out front. Before we take any antiderivatives, we should simplify what's going on inside. So 4 squared, we get 16. 1 over y squared, we get 1 over y. And all of this is dy, right? Take some antiderivatives. We get 16y minus antiderivative of 1 over y is ln of absolute value of y. Now since we're just dealing with positive values of y, I could do with or without this absolute value, but to be on the safe side, we might as well leave them in. Let's plug in and see what happens. Now, these numbers aren't quite as terrible as they look. So we get 16 times 4 gives us 64. ln of 4, we can just drop those the absolute value signs rather. Minus 16 over 16 gives us minus 1, and then distributing this minus sign, we get minus ln of 1/16, which is positive 1/16. Okay, so we can combine some like terms. 64 minus 1 gives us 63, and then if we want to get a little bit fancy, we can combine these two logs using log properties. So we're going to get ln of 1/16 divided by 4, right? So when you have a log minus another log, you get inside of the positive 1 divided by inside of the negative 1. Okay, just a little bit more simplifying. We have 63 pi times ln of 1 over 64.